Hello everyone, this is Chethan, a PhD scholar at Interdisciplinary Center for Water Research, Indian Institute of Science. I am working with Dr. Brahmadat Vishwakarma. My PhD topic is gravity field recovery from GRACE using improved atmospheric and ocean de-aliasing algorithm. GRACE is Gravity Recovery and Climate Experiment, a satellite gravimetry mission. Unlike other remote sensing satellites measuring the electromagnetic radiation, GRACE measures the distance between two satellites, which like using GPS and microwave ranging systems, which in turn relates to the gravity changes. The research problem is ever since the launching of the mission, we are unable to achieve the pre-launch baseline accuracy for monthly gravity field solutions, and there is a differences between various GRACE solutions. These are mainly due to background models used and the processing approaches. The background models are necessarily imperfect, and in fact the errors due to imperfect de-aliasing models are the largest contributors to the overall GRACE and GRACE follow-on errors. The research objectives contains to use the information about the uncertainty of the background models to find more appropriate stochastic model for GRACE observations. This can be done by estimating the variance covariance matrix of the errors using Kalman filter approach, and also extending the same approach to include the ocean tide background model uncertainties. The second objective is leveraging the high performance computing to process the GRACE level 1B data with and without the error model, and developing a data driven de-aliasing algorithm to reduce the dependency on the background models. The current progress is understanding the de-aliasing. Aliasing occurs when a signal is undersampled, leading to the a high frequency component of the signal is misinterpreted as the low frequency. For example, I have synthetically generated a data using various frequencies and I fit the least square estimation. So here we can see our model is fitting very well with the observed. But when I sampled at 5-day interval and tried to fit the least square model, it is matching very poorly. This is due to because it is not meeting the Nyquist criteria. And variance covariance matrix spatial covariances previously have derived uh, using technical note 2.4, and Andreas Quaz and Meyerger also uh, worked on estimating the spatial covariances using the by estimating the air model like autoregressive model parameters and constructing the covariance matrix with block topics. And I also created the framework for pre-processing the GRACE level 1B data and also process for 2005 January. And these are the some of the preliminary results showing at higher degrees, like at resonance orders like 15, 30 and 45, the errors are more. And I have also compared the GRACE GRACE tools derived level 2 errors and available JPL level 2 errors, and we can see in GRACE tools like at the very like fluctuations is very much because we haven't applied the de-aliasing model. And this is the variance matrix derived from the technical note 2.4. And some of the challenges are to run these GRACE tools, it's taking approximately 80 hours. So to complete mission, it can take like almost 2 years. And like whenever I try to estimate these lagged covariances and autoregressive model parameters, the in like often leading to the insufficient RAM issues. And this Kalman filter approach, it's a hypothesis, we need to prove that one. And also we need to define what is exactly errors in the ocean tide models. And international collaborations are very much necessary because the study related to processing level 1B is very much limited in India, and future challenges remain uncertain.